Almost everything around you arrived on a ship. Your phone, your computer, your television, the clothes in your closet, the food in your supermarket, even the chair you're sitting on right now. Most people never think about it. They order a product, it arrives. End of story. But behind that simple experience lies one of the most extraordinary engineering systems ever created. A hidden network connecting continents, an invisible machine that powers global trade, and at the center of that system are cargo ships, floating giants capable of carrying entire cities worth of goods across the world's oceans. Machines so massive that they challenge our understanding of scale, so complex that they operate like moving industrial ecosystems, and so important that if they suddenly disappeared, modern civilization would begin to feel the consequences within days. This is the incredible engineering behind modern cargo ships, the giants quietly carrying the world. The machines that built globalization, every day, thousands of cargo ships travel across the oceans. They connect factories to consumers, countries to markets, resources to industries. Without them, global trade as we know it simply could not exist. More than 90% of international trade moves by sea. Think about that for a moment. 90%. Not by truck, not by train, not by aircraft, by ship. And there is a simple reason why. Efficiency, moving cargo across oceans, is astonishingly economical compared to other forms of transportation. A single modern container ship can transport tens of thousands of containers in one journey, the equivalent of thousands of trucks, all moving together as a single machine. It's one of the greatest logistical achievements in human history, yet most people rarely see these vessels, and even fewer understand how incredibly complex they really are, because beneath their massive steel hulls lies an engineering marvel unlike anything else on Earth. But before understanding how these ships work, we first need to understand their scale, and that's where things become truly unbelievable. The giants of the ocean, photographs, can be deceptive. A cargo ship viewed from a distance often appears large, but not extraordinary. Then a human being walks beside it, and suddenly, the scale becomes difficult to comprehend. Some of the world's largest container ships stretch nearly 400 meters in length, longer than several football fields placed end to end. Their decks rise above the water like floating skyscrapers. Thousands upon thousands of containers are stacked with remarkable precision, each one carrying products destined for different corners of the world. From above, these ships resemble moving cities. From sea level, they feel almost unreal. The engineering challenge begins with a simple question. How do you build something this large and keep it floating? The answer lies in an extraordinary understanding of buoyancy, structural design, and weight distribution. Because despite weighing hundreds of thousands of tons, these giants remain stable enough to cross entire oceans, even through some of the harshest conditions on Earth. Some modern container ships can carry more than 24,000 shipping containers on a single voyage, but size alone isn't impressive. The real challenge begins when these floating giants start moving. The engines powering the world, moving a cargo ship, is not like moving a car, or even an aircraft. The masses involved are enormous. And pushing such weight across oceans requires extraordinary power. Deep inside these vessels operate some of the largest engines ever built. These machines can be several stories tall. Their individual components may weigh more than entire automobiles. Every second, massive pistons move with astonishing force, generating the power required to propel the ship across thousands of kilometers of open ocean. The scale is difficult to imagine. These engines are engineering masterpieces designed for reliability above all else, because a failure in the middle of the Pacific Ocean is not merely inconvenient. It can create serious logistical and financial consequences, which is why these engines operate continuously for weeks, sometimes months, under conditions that would challenge almost any machine. Yet despite their immense power, efficiency remains critical, because every drop of fuel matters when crossing vast oceans. Some marine engines are so large that technicians can literally walk inside parts of the machinery during maintenance. The container revolution that changed everything, perhaps the most important innovation in cargo shipping, wasn't a ship or an engine. It was a box, the shipping container. Before standardized containers existed, loading and unloading cargo was slow, expensive, and chaotic. Goods arrived in countless shapes and sizes. Everything required individual handling. Everything consumed time. Then containers changed the world. Suddenly cargo could move seamlessly between ships, trucks, and trains. The same container could travel across continents without ever being unpacked. Efficiency exploded. Costs dropped. Global trade accelerated. Entire industries transformed. Today, the container is so common that most people barely notice it. Yet it remains one of the most influential inventions in modern logistics. And modern cargo ships were built around this simple idea: floating platforms optimized for moving thousands of identical units with incredible efficiency. Sometimes the most revolutionary engineering solutions aren't the most complicated, they're the simplest. The standardized shipping container is often considered one of the inventions that helped create modern globalization itself. But transporting thousands of containers creates another challenge. How do you keep a giant floating structure stable when carrying so much weight? The science of staying afloat. A cargo ship's stability is constantly changing. Containers are loaded, fuel is consumed. Weather conditions shift, ocean currents evolve, every change affects balance. To manage this complexity, ships use sophisticated ballast systems. Large tanks fill and empty with seawater to adjust weight distribution. Engineers carefully calculate loading plans. Containers must be positioned strategically. Weight must be distributed correctly, because even small mistakes can create significant problems. The goal is simple: keep the vessel safe, stable, and efficient, even during storms, even while carrying enormous loads. It's a constant balancing act, one performed continuously throughout every voyage. And while passengers on cruise ships may notice rough seas, cargo ships quietly fight these challenges every day, often without anyone on land ever realizing it. A loading error involving only a small percentage of cargo can significantly affect how a massive vessel behaves at sea. Surviving the most powerful oceans on Earth, the ocean is beautiful, but it is also incredibly powerful. Storms generate enormous waves. Winds exert tremendous forces. Saltwater constantly attacks exposed materials. Every voyage becomes a battle against nature. Cargo ships are engineered specifically to survive these conditions. Their hulls flex. Their structures absorb stress. Their navigation systems monitor weather continuously. Captains and crews constantly evaluate conditions, sometimes adjusting routes to avoid dangerous storms, sometimes enduring them directly. Because unlike cars or trains, there are no roads across the ocean, only open water, and open water is unpredictable. This is where the true strength of cargo ship engineering becomes visible. Not in calm weather, but when the ocean reminds everyone who is truly in control. And yet, despite these challenges, global shipping continues almost continuously, day after day, night after night, year after year. Some waves encountered during major ocean storms can rise higher than multi-story buildings. But perhaps the most remarkable thing isn't the ship itself. It's the enormous system surrounding it. The global logistics ecosystem. A cargo ship never operates alone. Behind every voyage exists a global network. Ports, cranes, railways, trucks, warehouses, customs systems, navigation services, fuel suppliers, maintenance crews, and thousands of people coordinating every movement. A delayed ship can affect factories, retailers, supply chains, entire industries. The modern economy depends on synchronization, and cargo ships are one of its most important moving parts. They are not simply vessels. They are links in a planetary scale logistics machine. A machine so large and interconnected that most people never see the full picture. Yet they experience its effects every single day, whenever a package arrives, whenever a store is stocked, whenever products move between continents. A cargo ship was likely involved somewhere along the journey. At first glance, a cargo ship appears simple, a giant vessel carrying containers across the ocean. But beneath that image lies one of the most impressive engineering achievements of the modern world. Machines hundreds of meters long, powered by colossal engines, designed to survive the ocean, optimized for efficiency, and connected to a global logistics system that quietly powers civilization itself. Most people never notice them. Most never think about them. Yet without these floating giants, the modern world would look very different. Because behind every product, behind every shipment, behind every global supply chain, there is often a cargo ship, crossing an ocean, carrying the world forward, one container at a time. What surprised you most about modern cargo ships? Their size, their engines, their cargo capacity, or the global logistics system surrounding them? Let us know in the comments. But cargo ships aren't the only machines operating on an unbelievable scale, because some vessels are so large and complex that they function more like floating cities than ships.